This is video 922, and the goal of this video is to look at graphing nonlinear inequalities. So we still have the inequality symbol as you see here, in this case less than, but we want to graph the inequality. It's now a parabola. So we notice the x squared making it a parabola. So we have a couple of strategies for graphing parabolas. We're going to do the same things that we've done with graphing linear inequalities. It's the same graph, but now we have to shade all the solutions because there's an infinite number of points that work in this inequality. But first we have to graph the boundary line. In this case, the parabola, a U-shaped graph. So remember, a couple of ways to graph parabolas are starting with factoring. So we're graphing the parabola x squared minus 4x plus 5. And in graphing that parabola, we typically factor. In this case, I would get a diamond problem and a rectangle, and I would get 5x squared down here, because that's the two terms that would end up here. It doesn't matter which corners. And it has to add to negative 4x. So what multiplies to positive 5 but adds to negative 4? Well, the only way to get 5 is 5 and 1. And they never add to 4, so we try it negative. They both have to be negative because it's positive 5. But again, that doesn't add to negative 4. So this we would call not factorable. And when that's the case, we have to go back to old strategies for graphing, which include making a table. So we're going to make a table just to remind ourselves how to do that. And we're going to plug in numbers for x and find the values for y. So typically with parabolas, you have to do a wide range from like 3 to negative 3 would be a good idea. We can always add more numbers to our table eventually if we need to. So we're going to plug in negative 3. We're going to negative 3 squared minus 4 times negative 3 plus 5. So we're plugging it into the original rule that we have written because it was not factorable and not easy to graph that way. So let's see when I do that math. I get, let's see, oh, I get a big number. Hold on. Got to do that in my head. So 9 plus 12 is 21, plus 5 is 26. Plugging in negative 2. Negative 2 squared minus 4 times negative 2 plus 5. Negative 2 squared is 4 plus 8 plus 5. 4 plus 8 plus 5 is 17. So I'm just plugging this in my head. You can use a calculator to make a nice table in order to graph this function. In this one I get a smaller number of 10. Plugging in 0 is fast because 0 squared is 0. 4 times 0 is 0. We get 5. Now we try 1. And I'm going to get 2. 2 squared. 2 squared minus 8. So 4 minus 8 plus 5 is 1. 3 squared. 9 minus 12 plus 5 is 2. Looks like I am now, if you look at your points, the numbers were going down, and now they're starting to go back up. So that means my pattern will continue, and I'll repeat. This is actually the vertex of my line right here. 2, 1 is actually my vertex. And I'll start to graph it so you can see what I'm talking about here. 1, 2, 3, 2. So I've graphed these 3 points. I can graph 0 at 5. And I start to see this parabola. So I know the next point, 4, is also going to give me 5. And you can check that to make sure, but it's all based on this pattern that repeats itself on either side of the vertex. So my next point, 5, is also going to be at 10. 4, 5, 10. And the other one was negative 1, 10. And I have my nice U-shaped parabola. So that's the way to graph a parabola if you do not have the ability to factor it and find the zeros. So that is your graph for number 1. The parabola, parabola. Now hold on, we're not done because of course we are trying to graph an inequality. So one of the mistakes I made already is that since this is a less than symbol, I need to do a dashed line. Because I do not want to include the negative, I don't want to include the line, I want it to be a dashed line. So this is a proper graph here. Okay, now I need to test a point. So this is where it starts to get to be more new. I need to test a point to decide where to shade. 0, 0 is still your friend. Notice where 0, 0 is. We'd say 0, 0 is outside the parabola. It would include all of this shade. This part would get shaded if 0, 0 works. The other part of the graph is inside the parabola. If 0, 0 does not work, then I would shade the blue. So hold off on your shading until you test a point. So we test 0, 0. And I make sure that this works. 0, and I get 5. And I check this statement. I read it 0 less than 5. This is a yes. So the green part is where I'm going to shade. And the blue part should not be shaded. So this is my graph of the nonlinear inequality, the parabolic inequality. And you are done with this graph. So you are going to have to graph inequalities, parabolic inequalities. You still could graph and you still test a point. It's just a different type of graph. Let's try this next one. Let's see if factoring will work on this one, then we can review that strategy. So first of all, I see a common factor. I see a common factor of 2, which I pull out using the distributive property because now my numbers are smaller. Now I just need to factor this guy using my generic rectangle, my diamond problem. My generic rectangle will have x squared and 2 in it, giving me 2x squared, and it has to add to negative 3x. This one actually does work because negative 2x and negative 1x make negative 3x and multiply to give me positive 2x squared. Filling in the outside. I know I'm going fast here, but I'm assuming many of you are good at this, so feel free to pause the video to catch up and then check your work. So I have a new factored form, which is 2 times, don't forget this 2, times x minus 1 times x minus 2. Remember, the reason I factor is to find my zeros real quick. This parabola is 0 when x is 2 and when x is 1. So I have 2 zeros at x is 1 and x is 2. They're real close together. Those are my first 2 points. The next point that I can find is my y-intercept on the y-axis. And that, of course, means I'm going to plug in 0 for x. I'm going to go back to my original one. I'm going to plug in 0 for x. And I'm going to see that I get 4. So 0, 4 is my y-intercept. Using the line of symmetry, which is right in the middle of everything, which happens to be right here in between, I see another point across from the y-intercept here to make my U-shape. I also see my vertex is going to be at x equals 1.5. It's going to be a little bit negative because it's got to go below the x-axis to make the minimum point. So the last thing I can plug in is 1.5 in for x. Again, you can plug this into your calculator to get your exact value. In doing that, you'll get negative 0.5, and you'll see that it's going to go just barely below. And there's your parabola. You can see your U shape. Now notice it's a less than or equal to symbol, so that means I'm going to connect the points in a nice solid line. You could have made a table for this one. It would not have been the end of the world. Make a table. If this is hard for you to remember how to use the intercepts, you can always make a table. Now I have to test a point because it's an inequality. I test a point inside or outside of the parabola that I've drawn so far. And I always go back to my original inequality. So I'm going to test 0, 0 again because it's fast. You can probably do this in your head once you get good at it. 0, 0 is on the outside of my parabola. I test it, I get 0, 4. And I see that that's true because 0 is less than or equal to 4, so I shave outside. And I'm done with this inequality. So the steps are the same, you just have to review graphing parabolas. So give it your best shot, make a table between -3 and 3, or factor and find the zeros. But those next two problems you're going to try on your own before moving on to the next activity.